This Zoom session is being brought to you by the fractal fire. All right. Here we finally define trigonometric functions. This is the star of our show, so it's about time they got on stage. All right, now there are three ways we'll be defining trig functions. Sort of going backwards in time, I'll give you the most modern, then a sort of modern, and then an ancient definition. Most modern one talks about points on the unit circle. That way we'll be able to talk about acute, obtuse, breakback, and Pac-Man angle. So start with a unit circle. This equation is x squared plus y squared equals 1. Draw an angle with the positive real axis, the initial side, and the terminal axis being along here. Add an angle theta, which is what will be our variable, and it meets the unit circle at this point, x by y. Then we define the cosine as x, and the sine of the angle as y. And the rest of the trig functions are ratios of these. So for example, tangent is y over x, therefore sine over cosine. It's basically the slope of this line. Secant, cotangent is x over y, 1 over the slope of this line. The secant is 1 over x, therefore 1 over the cosine. The cosecant, written CSC, is 1 over y, 1 over the sine. Usually we'll just be using these with occasionally referencing these. Okay, because cosine is x and sine is y, and x squared plus y squared equals 1. Therefore, cos squared plus sine squared equals 1. That's a trigonometric identity. We'll be seeing more about that later. Okay, similarly, and since tangent is y over x, it's sine over cosine. Cotangent is x over y. Cotangent is cosine over sine. Secant is 1 over x, therefore 1 over cosine. Cosecant is 1 over y, therefore 1 over sine. Again, these also are trigonometric identities, which we will be seeing more of later. So okay, this is defining the trigonometric functions using the unit circle. X by y is specifically on the unit circle. We don't really need that. We're going to be a more general definition. We have our angle theta reaching out to x by y, not necessarily on the unit circle, but out a distance r. Now, according to Pythagoras, r is the square root of x squared plus y squared. Then, we'll have that cosine is, instead of just x, it'll be x over r. Sine, instead of just y, will be y over r. And the rest have similar relations. Tan is cosine over sine. Divide these out, you get sine over cosine, you get y over x. Cotangent is cosine over sine. Divide these out, you get x over y. Secant is reciprocal cosine, therefore r over x. Cosecant is reciprocal of sine, therefore r over y. And okay, if you draw a unit circle here, around here, then instead of x by y, you have the point x over r by y over r, and you get the same equations here. Now, here is a sort of ancient definition going way back to the Greeks. Here we'll have theta only be a right angle. There's only be an acute angle. So it's an angle in the first quadrant. And there's 3 sides to this triangle: adjacent, opposite, and hypotenuse. Adjacent corresponds to x, opposite corresponds to y, hypotenuse corresponds to r. And then translating these definitions in here, with the cosine of this angle here is adjacent over hypotenuse. Sine is opposite over hypotenuse. Tangent is opposite over adjacent. Secant is hypotenuse over adjacent, the reciprocal cosine. Cosecant is hypotenuse over opposite, the reciprocal of sine. And cotangent is adjacent over opposite, the reciprocal of tangent. Now, there's also a concept of complementary angles. We use the right triangle definition of an angle theta here. Right here is another angle, phi. They are what are called complementary angles. They add up to 90 degrees. Any one of them is 90 degrees minus the other angle. So that's what makes them complementary. Furthermore, opposite theta is adjacent to phi, and adjacent to theta is opposite to phi, but they have the same hypotenuse. Therefore, if you go back to here and switch adjacent and opposite throughout, you get that the cosine of theta is a sine of phi, the sine of theta is the cosine of phi, the tangent of theta is the cotangent of phi, the secant of theta is the cosecant of phi, the cosecant of theta is the secant of phi, and the cotangent of theta is the tangent of phi. Again, it's because we swap around adjacent and hypotenuse throughout. So in general, a trig value of an angle is the cotrig angle value of 90 degrees minus theta. So it's the cotrig of the complementary angle. Cotrig of an angle is trig of the complement, 90 degrees minus theta. There are special angles that sort of classical angles that everybody's expected to know. There's the 45-45 triangle, 90 triangle, and then there's the 30-60-90 triangle. If this is 45 degrees, then this is 45 degrees, and therefore, so these two angles would be the same, therefore these two sides would be the same. Let's set them equal to 1. If this is 1 and this is 1, then by Pythagoras, this diagonal will be square root of 2. And then we can read off trig functions quite directly. Cosine is adjacent over hypotenuse, 1 over root 2, which you can rewrite as root 2 over 2. Sine is opposite over hypotenuse, 1 over root 2, again, root 2 over 2. Tangent of 45 degrees is opposite over adjacent, 1 over 1, which is 1. And then for secant, it's reciprocal cosine, so therefore it'll be reciprocal of this, or root 2. Cosecant of 45 will be the reciprocal of the sine, therefore root 2. Cotangent of 45 is reciprocal of tangent of 45, so reciprocal of 1, which is 1. So just draw this triangle and you won't have to memorize this stuff. I constantly draw the triangle to memorize this. There's also the 30-60-90 triangle. This is what happens, this is what you get if you take a isosceles triangle with all three sides equal and all three angles equal and split it in two. Since we're splitting this side in two, I'll make these sides 1 and these therefore will be 2. So 2, 2, 1, 1. And if this is a right triangle, and this long side is 2, and this short side is 1, then if you work the Pythagorean relation, you get that this other short side is the square root of 3. 1 squared plus root 3 squared is 1 plus 3 is 4, which equals 2 squared. And okay, we look at this single triangle here, this half of the triangle, with a half angle of 60, which is 30 degrees, 30 degrees here, 60 degrees here, 90 degrees here, short side 1, middle side root 3, diagonal 2. And then, reading it off, cosine of 60 is adjacent over hypotenuse, 1 over root 2. Sine of 60 is root 3 over 2. Tangent is opposite over adjacent, root 3. Then secant will be reciprocal of cosine, therefore reciprocal of a half is 2. Cosecant of 60 is reciprocal of sine of 60. So reciprocal of this, that's 2 over root 3. And you can rationalize that to 2 root 3 over 3. Cotangent of 60 is 1 over tan 60. So 1 over root 3, and this rationalizes to root 3 over 3. Now, for 30 degrees, here's 30 degrees. Adjacent to 30 is a root 3. So cosine of 30 degrees is root 3 over 2, like this. Sine of 30 degrees is 1 over 2, like this. Tangent of 30 degrees is 1 over root 3, therefore root 3 over 3. And then for the secant, cosecant, and cotangent, we take reciprocals, which is reciprocal of cos 30 is sec 30, which works out to 2 root 3 over 3. Reciprocal of sine, the cosecant 30 is reciprocal of sine 30, reciprocal of a half, or 2. Cotangent 30 is reciprocal of tan 30, reciprocal of this, which works out to root 3. So, okay, as ever, trig 60 is cotrig of 30, cotrig 60 equals trig of 30. Now, there's also the 15, 75, 90 triangle, which has not gotten enough attention, I think, because it's a little bit more complicated, but it's really quite a nice triangle, and I think people should know more about it. It'll have, the shortest side is root 6 minus root 2. The middle side is root 6 plus root 2, and the long side is 4. And then you can define the trig functions from that. Sine of 15 degrees is root 6 minus root 2 over 4. Cosine of 15 degrees is root 6 plus root 2, that over 4. And similarly with 75 with the cosine and trig and cotrig swapped around. So for example, sine of 11 pi over 2. What is that? Well, pi over 2 is a 180 degree. No, pi over 2 is 90 degrees. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 90-degree turn. It lands at 0 by -1. Sine is the y coordinate. So sine of 11 pi over 2 is -1. Cosine is 0. Here they ask for a sine 90 degrees minus 3 tangent 180 degrees is what? Well, for a sine 90 degrees, you turn 90 degrees to 0 by 1. Its y value is 1. So it'll be 4 times 1 minus 3 times tan 180, turn 180 degrees around. Get negative, at this point is -1 by 0. Y over x is 0 over -1. So you have 4 times 1 minus 3 times 0 over -1. And after a bit of calculating, it's 4. Here they ask for the 6 trig functions of 2 pi over 3 radians. Now, if you work that out, that's 120 degrees. Okay. And so this angle is 60 degrees. And so we'll draw a 30, 60, 90 triangle here with diagonal 2, the adjacent side -1 because it's in the second quadrant, the y value, the height, root 3. So this point is at -1 by 3. And now we'll just use the definition of trig functions from the point in the plane. Cosine is x over r minus 1 over 2. Sine is y over r, root 3 over 2. Tangent is y over x, root 3 over -1, which is minus root 3. Secant is reciprocal of cosine, so reciprocal of -1/2 is -2. Cosecant is reciprocal of sine. Reciprocal of root 3 over 2 is 2 over root 3. Cotangent is reciprocal of tangent, so -1 over root 3. And these last two you can rationalize. That's optional. Here they ask for all 6 trig functions of 210 degrees. Now, 210 degrees is 180 plus 30. So we have a 30-degree angle like this. So let's draw a 30, 60, 90 triangle like this with 30-degree angle here. Diagonal is 2, far side is -1 because it's downwards in the third quadrant. Adjacent side is minus root 3 because it's left, third quadrant. So here we go. Cosine is adjacent over hypotenuse minus root 3 over 2. Sine is opposite over hypotenuse, minus 1 over 2. And tangent is opposite over adjacent, -1 over root 3 after canceling some -1s and so on. And rationalizing, you get root 3 divided by 3. Now, okay, secant, cosecant, and cotangent are reciprocals. Secant is reciprocal cosine. So you get -2 over root 3, which you can write as -2 root 3 over 3. Cosecant is reciprocal of sine. Reciprocal of -1/2 is -2. Cotangent is reciprocal of tangent. And reciprocal of root 3 over 3 is 3 over root 3, which is root 3. Now these last two, there's no way to do it by first principles. Well, okay, I mean, you can do it by first principles, but it's a long process. Fortunately, we have calculators. Back in the days before we had calculators, every trig book would have a trig table at the very back of the book. That's obsolete now. It's kind of funny. Anyhow, so Sine 28 degrees, you work it out. You have to make sure when you use your calculator, you have to make sure that you're in the correct mode, because if you push mode on the calculator, it'll say radians of degrees and you have to adjust it accordingly. So, okay, for sine 28 degrees, you adjust it to to degree mode, right? Sine 28 and get 0.46947. Tangent of pi over 10. When they don't mention, when it doesn't have a degree sign in here, it's radian mode. So switch to radian mode, write tan pi over 10, and make sure these are in parentheses, and get 0.32491 to 5 decimals. A calculator will give it to 9 or 10 decimals, which is usually more than you need. Okay, I think that's it for there. That's